Okay, kiddos, here's a little lesson describing how to solve inequalities. So here's an example of one. 2x minus 3 is greater than 7. This is really similar to solving equations, where we do something to both sides of the equation. So here we're trying to get x all by itself, so we add 3 to both sides of the inequality. We're going to divide both sides by 2, and what we end up with is this. So this says x is greater than 5. We can represent the answer like this in inequality form or in its graph form, which for this situation would be a number line. Notice how there's an open circle on 5 and all the values to the right are highlighted because x is greater than. Okay, so if x is greater than, we're highlighting to the right, and because x is only greater than and not greater than or equal to, we have an open circle. If it were this, we would have a closed circle. So there's our answer to that example. Number 2, it looks like this. So this is a little step up in difficulty. Notice how we have variables on both sides. So in order to solve this, you need to get the n all by itself and then the number on the other side. And whether to bring the n's over here or the n's over here is basically up to you. But what I saw here was that we have 17n here and 8n here. So if I brought the 8n over here, I would have a positive, and then I don't have to deal with that negative sign. So, I subtracted 8n from both sides, given this. Brought the number over here by subtracting 9 from both sides. And then when I divide, it looks like I'm getting a fraction. Freak out. That's okay. So we have that negative 11 ninths is greater than n. You could also write that as n is less than negative 11 ninths. Notice how the arrow part of the inequality sign points towards the n. That piranha eats the bigger number. So the negative 11 ninths is the greater number than n, meaning n would be less than, yes. So on the number line, 11 ninths is similar to 1 and 2 ninths, so somewhere around here. Notice how there's an open circle, and notice how it is graphed to the left. For this example, notice the change in directions. We're supposed to solve the inequality if possible. So remember that situation where we were solving equations and you ended up with either no solution, many solutions, or one solution? Well, this is similar. So here is our inequality. We're going to solve by simplifying and then moving variables around and stuff. Let's see what happens. First we're combining like terms. 2p plus p gives us 3p. And then we're going to subtract 3p from both sides, ending up with negative 7 is greater than negative 5. And if you think about the number line, 0 would be here, negative 5 would be here, negative 7 would be here. So yes, negative 5 is greater than negative 7. So because this is always true, our answer is all real numbers. Meaning this is similar to the many solution answer, but this is what we say. So any number, if you plug it in for p, this inequality will work. Let's take a look at the other type of situation. So here's in general some notes for you. If you're solving the inequality and you get something like this, that means there is one answer and this is the answer. If you get something like this that is true, you would say all real numbers. And if you solve down and get something like this that is definitely not true, 2 is not greater than 5, you would say no solution. So lastly, let's take a look at this example. Looks like we're going to have to do some simplifying, distributing, combining like terms, and solve and see what happens. So we distribute to get 9y plus 6. We combine like terms. 4 minus 3 is 1. So I rewrote the inequality right here. We're then going to subtract 9y from both sides, giving us this. 1 is greater than 6. No way. This is never true, so we say no solution. Alright, hope that's helpful.